Okay. We explained regarding this Armstrong and Axiom's rules, right? So Armstrong is the one who has find out these rules. Okay, why we need these rules means we have a right table, right? We need to find out the functional dependency on this table. With the help of this inference rule, we can find how many dependencies and what are all the functional dependencies are present in this table. Okay, what are the functional dependencies are present in this table? With the help of this Armstrong or inference rule, we can easily find out the how many functional dependency and the different types of functional dependencies are present on the table. Okay, we'll take the same example, employee. So first rule is reflexive rule. First rule is reflexive rule. Reflexivity rule. Okay. What this reflexivity rule means? This reflexivity rule and trivial functional dependencies are same. Reflexivity rule. What is trivial functional dependency? X determines itself. X, right? The set of attributes determine itself, and Y should be what? Subset of X. If these two conditions is satisfied on the X determines Y, that is on the functional dependency, then we say it as a reflexivity rule. Reflexivity rule means if we have a functional dependency, that is X attribute is a set of attribute determines Y attribute. In this attribute, on this attribute, if X determines itself and Y is a subset of X, then we say it as a what? Reflexivity rule. Example here on the same table you can take, right? Employee ID is the X value I have taken. Employee ID, comma, employee name determines employee name, right? Employee ID, comma, employee name determines employee name is, I have the value. Employee ID is what? Something I will take employee ID as 1, then A. So you can easily determine what? This value, A, like Y value. So the employee ID is 1 and the name of that employee is A. So if we have X value, we can easily find out the employee ID. The name of this employee, hold with this employee ID 1 is what? A. So, or employee ID determines itself, that is employee. So we can find out employee ID 1. We can easily find out the employee ID 1. Means, as I said, for example, RAM is having a SSN number or USN number 1. But I am asking the RAM, what is the USN number? He will see the same USN number 1, right? That is what, right? The subset, sorry, the attribute determined itself and it having a subset, right? RAM, your USN number is 1. I'm asking to the RAM again, what is your name? RAM, right? USN number 1 and name RAM. With the help of these two attributes, with the help of these two attribute value, I can easily find out the name of that student, that is RAM. That is what? Reflexivity rule. So reflexivity rule, X determines X and Y is a subset of X. So employee ID comma E name determines E name means, so employee ID 1 A. ID of that employee is 1, name of that employee is A. So I can easily find out with the help of these two values what is the name of that employee. It is what? Reflexivity rule. So reflexivity nothing but set of attribute. It is a set of attribute. X may be like employee ID, employee name. At the X part I have written two attributes. It is set of attribute always determine itself, and or subset of it, or any subsets of it, that we say it as a reflexivity rule. Okay, what is reflexivity rule? One is what? Set of attribute. Writing a definition here. Set of attribute always determine itself, and subset of, and or sorry, not and, or subset of any of its value, any of its other attribute. This is the reflexivity rule. Okay, this is reflexivity. Second rule is what? Second is transitivity. Transitivity. Okay, transitivity. What is transitivity? Transitivity rule. Right? I have x value. X determines y, and y determines z. Y determines z. Then x determines what? Z. This is what transitivity rule. Okay. If x determines y and y determines z, then x determines z. Here, you're going to find out the functional dependency on x and y first. Then y and z. If these two dependency are there, I'm repeating, if these two dependency are there, obviously x determines z should be also a functional dependency. No need of checking. I'm repeating, if x determines y and y determines z, if it's in this attribute, in between these two attributes, functional dependency is there, and in between these two attribute, functional dependency is there, obviously no need of checking for the third attribute. It also holds the functional dependency, right? And second one, if this attribute or in between these two attribute, functional dependency is there, but in these two attribute, functional dependency is not there. Okay, in between these two, only one attribute, in between these two functionality, only one functionality is having a functional dependency. Then it may have a functional dependency or it may not have a functional dependency. That is what transitivity is. Okay, if these two are functional dependency, no need of checking the x determines z. Okay, if this is the functional dependency and if it is not a functional dependency, second one, then we can't say it may be a functional dependency or it may not a functional dependency. Okay, example for this, I'm taking x as same employee ID, or can take employee name. Employee name determines salary, right? That is x determines, so this is x determines y. Okay, then we have to check here. What is the employee name? A. What is salary? 20. Either we have another attribute by the name. Yes, A. We have A 20k. Yeah, this is the functional dependency because at the two side function t1 of x, t2 of x, then t1 of y, t2 of y, both sides we having the same value, a20, a20, then it is a functional dependency. Okay, this part is a functional dependency, this holds true. Next we have to check the what? Y determines z. What is the y value? Here we have taken it as a y value as salary, right? So salary determines z. You can take z value. Z you can take any value here. Or you are taking the z value as a department number, right? This is y determines z. Okay. Then we have to check whether this is a functional dependency or not, right? Between the salary and department, 20k 5, then 20k 5. Again, these two are functional dependency. 20k 5 and 20k 5 is a functional dependency. No need of checking the x determines z. That is, x is what? Employee name. And the department is what? Some B department. Okay, no need of checking here. Employee name and department number. It's obviously it is the same. What is that? A5 then A5. Right? This is obviously a functional dependency. You can check, you may not check. Right? If these two are functional dependency, a third one is obviously a functional dependency. Right? Then, for example, if I will just remove a 20k and I will make it as 30 now. I will make it as a 30. Now, here I have just changed in the salary part, right? So employee name is what? A, then 20k. Here A 30k, correct? This part is not a functional dependency now. Not a functional dependency. So we are taking the y determines z. So Y is what? Salary, the department. 20K, 5. Then you have another 20K here. No, right? You're going to leave this one. Then 30K, 4. 30K, 5. Then here 30K, 4. By these two, it's not a functional dependency. We have one more 30K here, right? That is 4. So these two becomes the functional dependency. Correct? These two becomes the functional dependency. Between employee 2 and 3, 30K is 4, 30K is 5. Even though we have the same salary, but department number is 4. These two are not a functional dependency. Correct? Then we're checking with some other value, right? After comparison these two value, we have to compare this value with this value. 30K, that is 4, and 30K, this is 4. We have a functional dependency. Then we have to check this one, because the first part here, first functionality is not a functional dependency. Second functionality is a functional dependency. So we're going to check with the third part. Okay, if both are not a functional dependency, obviously the third S determines Z is not also not a functional dependency. This is regarding a transitive rule, right? What transitive rule says? If either one of the functional dependency should be there between the X, then only it going to find at the last part. That is the this part will be obviously a functional dependency. That is what transitivity rule says. Okay, then third one, augmentation rule. Augmentation rule, right? What augmentation rule says? If X determines Y, then X A determines Y. Okay. Before explaining this one, what is augmentation means? What augmentation means? We are just trying to expand. We are just trying to expand the value, right? Here for these two attributes, X attribute and Y attribute, I am adding, right? I am adding the common attribute for X and Y. By adding the one more attribute to the X and Y, the functionality has been expanded. The functionality has been expanded. For example, here you take employee ID determines employee name. Here employee ID determines employee name. Then I am just adding the one more attribute to the X and Y now, right? Employee ID is there. I am adding the salary. I am adding the salary. So E name, the same attribute I am adding. Okay. Is there any difference? We will check here. Before adding the attribute, employee ID is what? 1, and the employee name is A. Right? I am adding the salary. I am adding the salary for both attributes. Does it make any difference? Employee ID 1, comma, salary is what? 20K. Employee name is what? A. Salary is 20. Right. With the help of employee ID and the salary, I can easily find out the employee name and the salary. Right. It doesn't make any change. Right. For some requirement, we are going to add the other attribute. But by adding that other attribute, it will not harm the present functional dependency. Present functionality will not get affected. That is what augmentation rule. Augmentation rules means adding same set of attribute. Augmentation nothing but adding same set of attribute. Adding same set of attribute. Adding same set of attribute to both left hand side, nothing but it is X and Y, left hand side and the right hand side of the functional dependency, and it leads to a valid dependency only, Okay, this is regarding the augmentation rule, right? These three, reflexivity, transitivity, and augmentation. These three we say it as a primary inference rule. These three we say it as primary inference rule. Why means with the help of these three, we can easily find out all types of functional dependency it is present in this relation employee or not. Okay, with the help of reflexivity, transitivity, and augmentation, with the help of these three rules, we can easily find out the types of functional dependency on the table employee. Right, then we have another tree has a secondary rules. We have another tree has secondary rules. Why we need secondary rules? We have already reflexivity, transitivity, augmentation. With the help of these three only, we can easily find out what the types of functional dependency on the table. Then we can only find out this one. With the help of these three, we can find out. Then why we need another three as a secondary rule? Like one simple example, right? You have a LD subject, right? Logic design. With the help of NAND gate and XOR gate, NOR gate. With the help of NAND gate and NOR gate, with a universal gate, you can easily find out all the values, right? Then why we need AND gate, OR gate, right? To make the operation simple, right? To make the operation simple, we have AND gate, OR gate. In the same way, to make the operation simple, we have a secondary inference rule. We have a secondary inference rule. That is another three others acting as a secondary inference rule. That is, first one is what? Union. Union. Okay. If X determines Y and X determines Z, then X determines Y, Z. Okay. I know the value of, we can easily find out if X determines Y means, if X determines Y, it's a functional dependency, and X determines Z, it's a functional dependency, then X determines YZ. Then with the help of X, I can determine Y also, I can also determine Z also, right? Example, employee ID determines employee name and employee ID determines salary. Right? This is the X determines Y and this is X determines Z. At the X side, at the left hand side, we have the same attribute, EID and EID. If X determines E name and salary, at a time, X determines both E name and salary. X determines both E name and salary. This is what? Union rule. This is what? Union rule. Okay. Then fifth one is decomposition. Decomposition nothing but splitting, right? Decomposition nothing but what? Splitting. I have, if X determines YZ, then X determines Y and X determines reverse of union property. Reverse of the union property, right? So X determines Y, means employee determines E name. Here employee determines both, right? E name and salary. Here you can take same example in reverse manner. If employee is a X value, YZ is what? Employee name and salary. You can easily split. Employee can determines the E name also, employee determines the salary also. That is, we say it as a decomposition. That is the splitting. We have the two attributes at the what? Right hand side. Right. We have to remember here, we have to split the right hand side attribute only. We can't split the left hand side attribute. Okay, if you split the left hand attribute, the meaning of that functionality will be changed. So we have to remember while applying decomposition rule, we have to decompose, we have to split only the left hand side attribute value. So right hand side should remain the same. X determines Y, then X determines Z. This is what a decomposition is. Last one is pseudo transitivity. Last one is what? Pseudo transitivity. Transitivity. Okay. What is the pseudo transitivity? If X determines Y and YZ determines A, then XZ determines what? A. Okay, if X determines Y, I know the value. X is what? Employee ID, Y is employee name. If determine, this is the functional dependency, then YZ, you can take something, I'll take the example here, then you will understand. Example, if X is what? Employee ID determines employee name. Okay, then YZ determines A. Employee name determine, or employee name comma salary, equal to YZ, two attributes, combination of second side we have a set of attributes, it is E name and salary, determines A. You can take any other attribute, department, number, nothing but XZ. X is what here? Employee ID, then Z is what? Salary determines department. You take the value here, you just give the value according to the table. Okay, you take the employee ID as 1, then the employee name as A, right? Employee name is A, and the salary is what? 20K. The department number for this one is okay. You take department number as initial what we taken department number as 5, right? Next, here employee is 1, salary is 20K, department number is 5. Remains the same, right? With the help of employee ID, I can find out the employee name. With the help of employee name and salary, we can find out the department number. If these two are functional dependency, if these two holds a functional dependency, obviously the third part XZ, it determines department number, is also a functional dependency. So we have 3 primary rules and 3 secondary rules. Okay, first primary rule is what? Reflexivity. Second is transitivity and augmentation. And we have secondary rules, that is union and the decomposition, and last one is the pseudo transitivity.